Good morning to all. Today we are going to see the next point, ion chromatography. In ion chromatography, there is a principle, instrumentation and their application. First we see the diagram of ion chromatography. Here you can see the first eluent. Next one is pump. Third one separator. Second suppressor. Next one detector and recorder. First we introduce about this ion chromatography. Here is the principal reason of this technique is speed of analysis. One can easily perform separation in few minutes, and this speed or rapidity of separation may be attributed to efficient detector which are available in both systems. In comparison, the ion exchange chromatography, in spite of being a selective and versatile method of separation, and the analysis could be carried out by using spectrophotometry or polarographic technique. Here both cations or anions are used, so it is termed as ion chromatography. I just repeat the principal advantage of ion chromatography are its selectivity, speed of analysis, sensitivity of detection, and the facility of simultaneous analysis. For the separation, minimum amount of time is required, and the concentration of the sample is in nano, that is 10 raised to minus 9. From this you can understand the very small volume of liquid are required, and the disadvantage is here multi-element separation is takes place, and the analysis with greater selectivity of separation also takes place. Here you can see in the picture eluent is there. This eluent is very dilute or weak. Here it is possible to use a variety of resin and the detector in the system for analysis. This is all about the introduction of ion chromatography. Now we move towards the instrumentation. Here first you see the eluent. Eluent is eluents are not same for this method. Just we saw that here it's a cation or anion exchanger. So for anion exchanger, the eluents are used which are sodium sodium hydroxide, sodium bicarbonate, sodium carbonate, sodium iodide, just like this for anion exchanger. And for cation exchanger, eluent like citric acid, tartaric acid. Next one is pump. And on that the injection valve is there. Here you can see the injection valve where they inject the sample. On that pump, injection valve is there, and the sample is inject into it. Here Double piston pump is used, which can electronically control the flow rate of the liquid with accuracy. Here also the another diagram also there, where the injection valve on the separator column, not on the pump. That is, the sample is injected on the top of the column, separator column, and the pump control the flow rate of sample. Next one is separator or separator column, which contain the ion exchange resin. It is specially manufactured for the ion chromatographic technique. In short, in separator column, separation takes place. After that, the solution is passed to the suppressor. Suppressor column. This is the most important component in chromatographic column. Here usually separation of the eluent after emerging from the column with the ion, it is directly taken for analysis. That eluent. Such analysis involve volumetric, spectrophotometric, polarographic method, which by and large are time consuming. In suppressor column, for cation and anion, uh, the eluent from the column is once again passed on the suppressor column, just I said, lead to the elution of anion or cation, that as the case may be, it giving a good signal by using the eluent respected to cation or anion. Just before I said that which eluent are used for cation and anion for anion separation, it giving good result or signal uh, in the detector. This suppressor column point is, I will explain in descriptive way. This is the separate question they ask you for the exam. Describe the example. Describe the suppressor column or principle of suppressor column. When I will explain this point, that time you will better get it. Next is detector. uh, Here different types of detectors are used, that are conductivity detector, photometric detector, fluorometric or amperometric detector. Here the intensity of conductivity is obviously related to the number of ions separated. And the photometric detector, the sample after elution is passed through the premix column to interact with chromogenic ligand. And the amperometric detector, which are used for the ions which undergo for oxidation or reduction reaction. I forgot that. Here for the column, the inert material which is used is KLF and Teflon and polypropylene also used. What I said for column construction of column, inert material which is used. Here you can see the KLF, Teflon, also polypropylene, and last one is recorder. Here whatever signal is there is fed to the recorder. From that we can measure the concentration of iron. Here shortly explain. First one is eluent, second one is pump. On that injection valve is there. From there sample is injected and then passed to the separator column where separation takes place. Next suppressor, where by using the eluent separation takes place and give the better signal of anion or cation. Next is detector, where detection takes place, detection of ion. Next one is recorder, where the record this signal. Next is application. Here just I said separation of anions as well as cations. This technique is used in petrochemical industry for determination of sulfur compound in determination of sulfur compounds and mining for analysis of inorganic ions and heavy metals. Also it is used in field like medicine, agriculture, pharmaceutical, mining, and also just I said petrochemical industry. Next one is it is used for sugar, analysis of sugar and amino acid. It is used in chemical industry also for analysis of impurities and agriculture product analysis, and also for micronutrients in soil, analysis of micronutrients in soil. Thank you.